The path of creating self-driving cars started in the 1920s when experiments were conducted on self-driving cars. For example, in 1925, Houdina Radio Control Center controlled a radio-controlled car called American Wonder down the streets of New York City that did not have anyone present in front of the steering wheel. The car had a transmitting antenna that caught radio impulses from a second car that followed it. In the 1930s, further research was done on self-driving cars that allowed us to make it a reality today. Norman Bell Geddes held a Futurama exhibit in the 1939 World Fair. Radio-controlled electric vehicles were shown on display. Norman also wrote a book that described future advances in self-driving vehicles. In 1953, RCA Labs built a mini car to be controlled by wires. This sparked researchers to create detector circuits and embed them into roadways in Nebraska and New Jersey. In 1956, General Motors held an exhibit called Firebirds. Displaying the power of these circuits, they presented several electric self-driving cars that could be driven on the highway. According to Gen U, in the 1960s, electronic roadway projects were done by Ohio State University, the U.S. Bureau of Public Roads, and the Bendix Corporation that helped spark inventions in the self-driving car industry. Also in the 1960s, in the United Kingdom, research was done on drive-by-wire cars, and a car that can drive 130 kilometers an hour was invented, and trials done on the car found it was actually safer than having a person drive a car. However, electronic roadways never became popular, and thus this version of a driverless car was never implemented. Moving on to the 1970s, a Stanford cart was created. This was meant to be a moon rover project, but as the team created the video technology, they realized it can be implemented in vehicles to help people see what obstacles are near them while they back out of parking lots. In the 1980s, a vision-guided Mercedes robot van went 39 miles per hour down the street in Munich, Germany, because it was able to use visual data to control the steering wheel. In the 1990s, in 1995, the Eureka Prometheus project was created by an organization that wanted to invest in this technology in hopes of creating safer roads. This driverless vehicle traveled 2,797 miles, and this was known as the No Hands Across America journey. The pathway to creating a fully self-autonomous vehicle continues when DARPA holds a grand challenge in 2002, offering top research facilities a $1 million prize if they can build a driverless vehicle that can travel 142 miles in the Mojave Desert. No contestants were successful. In the 2000s, the creation of self-parking brought back hope to the ability of being able to create a self-driving car. According to Luke Dormel from digitaltrends.com, in 2003, Toyota's Japanese Prius model began offering parallel parking assistance. 1 year later, BMW came out with their own parking assistant. In 2009, Google begins developing its self-driving car project, Waymo, in secret. Google revealed a few years later that its self-driven cars have traveled over 300,000 miles using computer guidance without an accident occurring. In 2016, the first autonomous car death takes place when a passenger riding Tesla Model S is killed in autopilot mode when it cannot brake in time. In 2018, an Uber self-driving car killed a pedestrian in Arizona and is the first fatal accident regarding a self-driven car in the United States. Despite the fatalities, in 2018, auto companies such as General Motors, Ford, Mercedes-Benz, and BMW are developing their own self-driving car capabilities. During CES 2018, Nvidia revealed a car chip called Xavier that will have artificial intelligence and is collaborating with Volkswagen to do so. According to Bonnie Gringer, there are many vehicles today that are semi-autonomous because of the safety features they have. Brands like Mercedes-Benz, General Motors, Nissan, Toyota, Audi, and Volvo are coming out with driverless cars. Technology is expected to improve, and the vehicles are expected to become fully autonomous by 2025.
When it comes to the cost of self-driving cars, there are a lot of factors that play into it. The level of automation, the sensors that will be used, including cameras, radar, ultrasonic, and LiDAR, the processors, and the software. LiDAR is one of the most expensive units on the car, ranging anywhere from $75,000. According to TechMerce, there are 5 different types of automation: driver assistance, partial automation, conditional automation, high automation, and full automation. Each of these levels of automation costs a different amount depending on which is used. In 2016, GM spent $581 million to acquire self driving cars. According to Paul Leinart, the estimates for the cost of self driving cars can range anywhere from $70,000 to $150,000. However, he expects by 2025 the prices will decrease dramatically to about $5,000 due to technology developments. Benefits of self-driving cars include less accidents on roadways and saving time and fuel. According to the Safety Traffic School in 2012, there were 30,800 fatal car crashes, and these accidents caused 22,912 people their lives. With self-driving cars, we could decrease this number and save more lives. If you do not have to drive, you can be a lot more efficient in your everyday life, meaning you can send emails for work, make phone calls, and research information for a meeting safely in your commute to work. How these cars can help on saving time and fuel is now drivers do not have to waste their time trying to find a parking lot closer to their destination. Their car will drop them off and find a parking spot itself, making optimal decisions on where to park and the positioning of other vehicles. So, with this being said, the car is using less energy searching for a parking spot and saving time for the human occupants. There are risks when it comes to self-driving cars. They can be hacked and malfunction, and people will unfortunately end up losing their jobs. Hacking can be done in numerous ways and by many people. The hacker could take control of the vehicle's steering or acceleration, putting the drivers and other people's lives at risk. Terrorists could also gain access of these vehicles and use them as weapons. There is also a chance that the system can malfunction and cause the vehicle to act unpredictable or stop altogether. This can be very dangerous if the car is driving at a high speed. According to AV, taxi, bus, and truck drivers are in danger of losing their jobs. The numbers are astonishing. To be exact, 180,000 taxi drivers, 160,000 Uber drivers, and 500,000 school bus drivers' jobs will be lost if self-driving cars become as popular as people think they will be.
The majority of autonomous cars use a series of cameras to assist in navigation. Forward-facing narrow-view cameras, forward-facing wide-view cameras, an additional forward camera, forward-facing side cameras, rearward-facing side cameras, as well as rearward-facing main cameras. Majority of autonomous cars use something similar to this to allow the car to see where it is in space, as well as maneuver around other vehicles. Also used for assistance in navigation are ultrasonic waves. Ultrasonic waves are sent and received from the car to allow the car to self-evaluate its location better. Radar and LiDAR are also used to assist in this. Radar sends electromagnetic waves, while LiDAR sends laser. Software is designed to take the images captured from the assorted cameras and distinguish between pedestrians, vehicles, road signs, and any other objects a vehicle can encounter. Sensors, radar, LiDAR, and ultrasonic waves are used to compute the exact location of the vehicle on the road. To handle all of the onboard computing, the car itself has to be very capable and reliable when it comes to computing and technology. Most onboard computers in autonomous cars are 40 times as powerful as top-of-the-line desktop. The software goes through 3 separate cycles: perception, planning, and control. Perception sorts the images captured and decides what they are. Planning uses the sorted images to make decisions based on a pre-programmed hierarchy, which leads into the control cycle. The control cycle takes the hierarchy and puts it to action. Based off the hierarchy and the decision made by the computer, the car physically takes action. Software is also designed to provide a frontal collision warning, side collision warning, provide automatic emergency braking, as well as manipulate the high beams of the car to provide adequate lighting for the vehicle's own cameras. As you'll see later on, autonomous vehicles are very safe compared to self-driven vehicles.
There is a lot of technology that goes into making an autonomous car work, but most of them have sensors, which include lasers, radars, and cameras that detect objects in all directions. This information is sent to the computer, which is essentially the brain of the car. The interior of the car is made for riding, not for driving, and the car is powered by electric batteries. It has a backup system for steering, braking, and computing, and the shape of the car is usually rounded to maximize sensor field of. Although there is a lot of technology going into an autonomous car, there are five core components, and the first ones are radar sensors. These essentially help the car figure out where it is and what is happening around it. They are typically placed on the bumpers of the car, two at the front and two at the back. These help the vehicle detect road dynamics such as detours, traffic delays, vehicle collisions, and other obstacles by sending a signal to the onboard processor to apply the brakes and move out of the way. This technology works in conjunction with other features of the car to send accurate signals to the processing unit of the vehicle. The next core components are optics, which are the high-powered cameras. These cameras are used to identify road markings and traffic signals. Although some self-driving cars can operate using just a single camera, most autonomous cars require several cameras mounted to the vehicle's exterior with slight separation in order to give an overlapping view of the car's surrounding. This proves to be safer. The goal of a driverless car camera is to help the car's computer build up a composite picture of the surrounding world in order to drive safely. The technology behind these cameras functions similar to the human eye, which provides overlapping images to the vehicle's computer before determining things like depth of field, peripheral movement, and dimensionality of objects. Next up is LiDAR, which means laser illuminating detection and imaging. Although one of the most expensive parts of the car, it's also one of the most important ones because this essentially determines where the car is and also what is around it other than the cameras. The LiDAR unit, which looks like a spinning siren light, provides driverless cars with highly accurate long-range detection with ranges of up to 100 meters. As it spins, it continuously scans the world around the car and builds a 3D omnidirectional view to allow the car to see potential hazards by bouncing a laser beam off of surfaces surrounding the car in order to accurately determine the identity and distance of the object. This unit generates raw information about the world, which is then sent to the car's brain to process just like a human driver would. The LiDAR works by emitting a laser that generates and sends the beam outside of the rotating cylindrical housing. After the laser beam bounces off an object, the laser light returns back to the inside of the housing. Then the gathered light is bounced downward to the receiver, which interprets it. And then the car computer then takes this data and generates a map of its surrounding. The last two core components are GPS and processors. GPN stands for Global Positioning Software. The GPS in a driverless car is not much more different than Google Maps navigational software. While having GPS may seem like a no-brainer, it's actually a vital part of a self-driving car technology. The major difference is that driverless cars require GPS to navigate the car, while human-driven cars do not. It looks at all the roads, chooses the best path, and is often better than people at doing it. This is why it maximizes time and safety. The GPS works in conjunction with radars, sensors, and LiDAR to safely maneuver the vehicle to its final destination. And then lastly, processors. Autonomous cars have many computers on board to make sense of all the car instruments, with some cars running more than 20 different processors. All of the data generated by the cameras and sensors mentioned above is processed in real time as well as modeled behavioral dynamics of other drivers, pedestrians, and objects around the vehicle. While some data is hard-coded into the car, such as stopping at red lights, other responses can be learned based on previous driving experiences through machine learning. For example, actions such as steering, accelerating, and hitting the brakes are all controlled by the processed information.
Future trends. There are 7 future trends that we will see in the near future if autonomous cars become a successful invention. The first is driverless cars. The first truly driverless car will be a game changer. But don't expect to see widespread acceptance and production of driverless cars for at least another decade due to the need for a connected infrastructure and advancement of other technologies, such as vehicle to vehicle. We will then be introduced to AI interfaces. Automakers will provide artificial intelligence software in vehicles' infotainment systems that will serve as a virtual personal assistant. Automakers are expected to introduce models with AI interfaces as early as 2019 or 2020. Automotive telematics play a vital role in assessing driver behavior for a wide range of purposes, from determining a more accurate insurance premium to learning more about when and where people drive. Future trends continue. Vehicle to vehicle technology, as the name implies, allows vehicles on the road to talk to each other by sharing data on speed, road conditions, and other factors through an ad hoc network created among vehicles. Vehicle to vehicle technology shows great promise in helping to avoid crashes, ease traffic congestion, and improve the environment. Innovative sensors monitor and regulate a car's operation and provide the foundation for autonomous driving by sharing important data and in demanding applications such as engines and brake and transmission systems. Sensors such as LiDAR, radar, cameras, and ultrasonic are significantly impacting auto safety, security, and vehicle maintenance costs. The totally connected car. There's a good chance your next car will be every bit connected as your smartphone, with access to the internet and the cloud. Don't be surprised if at some point in the not too distant future, internet access will be as important as fuel efficiency and engine power when you purchase your next car. Widespread access to a connected car is not here yet, but I agree with the experts who predict that 90% of new cars will be connected to the internet by 2020. Brain to vehicle technology. Brain to vehicle technology uses a device to measure brainwave activity, which is analyzed by the vehicle's autonomous systems and used to predict and eventually anticipate drivers' behaviors. B2B technology may not be for everyone. It requires the use of a headset dotted with electrodes that either press directly against a person's scalp or come as close as possible. However, predictions are that B2B application can help drivers avoid accidents caused by abrupt lane changes and other unsafe driving practices. We're still a ways from seeing the wide adoption of B2B technology based upon the advancement of supporting technologies.
Now that we talked about the history, the overview of IT, relevant IT components, relevant costs, benefits, risk, and future trends, let's dive into some good old-fashioned fun facts. First, I want to talk about how self-driving vehicles will generate big business. According to Boston Consulting Group, it estimates that driverless car markets will be worth $77 billion by 2035. Furthermore, one quarter of all cars will be autonomous by 2040, according to Brookings Institution. There are still many regulatory hurdles expected in the adoption of driverless cars, but the government is backing driverless cars and proposed a $4 billion budget over the next decade to test out and drive driverless cars. That alone should indicate to you that driverless cars is going to be business because the government is going to back it up with $4 billion. And not only do driverless cars have the backing of the federal government, but also are being endorsed by major companies such as Google and Tesla. Oh, but there's more. Self-driving cars can't be big business if they're not on the road. In 2015, a car successfully drove itself across the country. The Roadrunner drove from San Francisco to New York, navigating 15 states and over 3,400 miles over the course of 9 days. While there was a driver behind the wheel, the car tackled 99% of the trip on its own. Like I stated before, Google is endorsing self-driving cars. Google currently has more than 50 self-driving cars on the road. which includes 22 Lexus SUVs fully equipped with autonomous technology and 33 smaller self-driving prototypes. According to Google's testing, self-driving cars will minimize human error by at least 90%. But there is a downside to self-driving cars. Initially, self-driving cars are said to make traffic worse. The government agency expects road delays to tick up by 0.9% when a quarter of all cars become automated. Did you know that people have been talking about self-driving cars since the 1930s? At the 1939 World's Fair in New York, GM's Futurama exhibit included driverless technology, and experts were sure that it could be a reality by the 1960s. Clearly, we're a little behind on that. But when we do finally get those self-driving cars on the road and in the use of people, they could save us thousands of dollars in insurance. The time has come for us to wrap it up, but not without tying all of this stuff together. In conclusion, history shows that people have been working on autonomous vehicles since the 1920s. Over time, technology has evolved to produce an actual autonomous model that will be used for purposes like delivery, safe driving, and helping the environment from pollution. Although it's very expensive, its benefits includes less accidents on the roadways, saving time for consumers, and saving fuel. In the long run, people will become more connected to their cars and the internet while driving. This promotes vehicle to vehicle connectivity, which will allow cars to talk to each other. Wow, that's amazing. Who would have thought that models from the 1920s would turn into a reality in recent years?